Hello, and welcome back to the channel. So, what if I told you you could build a PC that's completely silent, which means no fans, no pumps, just pure passive engineering? And the crazy part? You could start planning it today without buying a single new part. So let's break down the unconventional cooling tricks that make it possible. So let's start by talking a little bit about heat transfer. So every fan in your PC is fighting a losing battle against physics, unfortunately. But let's make that battle simple. There are actually only three ways heat can escape your system: through conduction, convection, and radiation. Conduction? You can think of the heat pipes like thermal highways moving energy from your CPU to metal fins. And conduction itself is the process where heat travels through direct contact. So it's kind of like a chain reaction of vibrating atoms passing energy along. In a PC, what that means is that the heat moves from the hot CPU surface into the cooler metal of the heatsink. And this transfers energy faster than rush hour traffic ever could. Then you have convection. So this is where basically your case becomes a mini chimney. The hot air rises, cool air enters, and the cycle repeats. This happens because warm air is less dense, so it naturally moves upwards while cooler air rushes in to take its place. So even without fans, this constant motion itself helps carry heat away from your components through fans and make the process really quite efficient. Then you have radiation. So even the metal surfaces themselves slowly bleed heat into the air. Not through contact or airflow, but by emitting infrared energy. It's actually a slower process compared to conduction or convection, but it's always happening in the background. And actually, once you understand these three methods of heat transfer, you realise that silent PCs isn't magic. It's actually just very smart thermal design. Still with me? Great. Well, let's now talk about another one of the coolest and quietest technologies hiding inside of many modern GPUs. I'm talking about vapor chambers. So you can think of these as liquid cooling without pumps. So inside that flat metal plate is a tiny sealed ecosystem and also a small amount of liquid, usually water. And what happens is it evaporates when it touches the hot GPU die. Then the vapor travels across the chamber, spreads the heat evenly, and then condenses it back into liquid, ready to start that process all over again. So there's no fans, no moving parts, just pure thermodynamics doing the heavy lifting. And actually, many manufacturers like EVGA and ASUS have vapor chambers in their high-end cards to pull the heat away faster than your traditional copper base plates. So that thin layer of vapor keeps the temperature uniform across the entire surface, which means the heat sink can work for longer and much more efficiently. And when you actually look at the thermal benchmarks themselves, the difference is clean vapor chambers can drop GPU hotspot temperatures by as much as 8 to 10 Celsius compared to standard heat pipe designs. And that's the secret, I think. Because the vapor chamber spreads the heat so evenly, your fans don't need to spin up as fast. And that's why, actually, high-end GPUs can run silent under load. Now we're on to next-gen thermal interfaces. So we're moving from those big metal plates to something much smaller but just as important. That thin layer that connects your CPU or GPU to its cooler. Because when it comes to silence, every degree does actually count. So you might remember my deep dive on thermal paste and how even the smallest air gaps can hurt performance. Well, this next generation of thermal interfaces takes that idea to a whole new level. So the first one I'm going to talk about is graphite thermal pads. So these are reusable and deliver consistent performance over time. What that means for you is no mess, no reapplication, and no risk of pumping out like traditional thermal paste does. Just place it once and pretty much forget it. Then there's the very science fiction option, which is carbon nanotube compounds. So these use tiny microscopic carbon structures to transfer heat incredibly efficiently. So we're talking better thermal conductivity than most pastes on the market today, with the long-term stability to match. And finally, phase change materials. So these are solid when cool and liquid when hot. So they literally melt into place to form a perfect contact with your CPU and lid. When the system cools down, they reset for the next session. Basically, each of these technologies aims towards the same goal: maximum heat transfer with zero noise. It's one of the easiest ways to gain a few extra degrees of efficiency, which in a silent PC can make all the difference. Now let's move on to unconventional method number 3. Now this is where things get a little bit radical. What if your case itself became the heatsink? So fanless enclosures from, I think this is how you say it, Streacom, Akasa and HDPLEX use thick aluminium panels connected directly to the CPU via heat pipes. So that turns the entire chassis into one massive passive cooler. And the bonus tip with this is its a vertical orientation boosts that natural convection, making your PC a silent chimney of heat flow. And actually, when you calculate the total surface area these designs can rival and sometimes beat when put up against a tower cooler with fans, all while staying 100% silent. So, for example, a typical tower cooler has about 6,000 square centimeters of surface area. A fanless chassis like the Streacom DB4, over 20,000. That's actually more than triple the area for the heat to escape silently. So now we've got the sciencey bit over, let's go to the real world application. So let's make it practical. Question is, can you actually use this in a real build? And the answer is yeah, absolutely. Several content creators and silent PC builders have proven you can edit, stream, or even game quietly with the right parts. And here's what to focus on: low-TDP CPUs, efficient GPUs, and power supplies with hybrid fan modes. You will sacrifice some peak performance, but the trade-off is a PC that you could pretty much sleep next to on full pelt. For recording studios, home theatres, or minimalist setups, it's actually a little bit of a dream come true. So we have hit the point where cooling isn't just about brute force, it's actually more about design. With vapor chambers, next-gen interfaces, and passive chassis, silence isn't impossible. It's just engineering elegance. So next, I'm going to take this all a little bit further, and I'm going to show you how to choose components for a fully fanless build. So let's imagine a PC so quiet you can literally hear your own thoughts. No fans, no pumps, just raw performance and perfect silence. Let's walk through exactly how to pick the parts that make all of this possible. So, to start with, we already know how heat transfers and moves. We've covered that bit. Now it's time to build on that quite literally by choosing the right components for a completely fanless setup. So no gimmicks, no RG blenders, just engineering precision and the sound of complete silence. So the component that we're going to start with, because it is at the heart of every build, is your CPU. And in a fanless system, thermal design power, or TDP, is literally everything. You want a chip that's designed for low heat and high efficiency. So you can think of Intel's 65 watt non-K models like the i5 14600 or AMD's 65 watt Ryzen 7 7800X3D. The X3D is especially interesting because it's incredibly efficient and you get high gaming performance at surprisingly low temperatures. But if you plan to go fully passive, make sure you keep your CPU under 65 watts TDP, ideally 45 if possible. That keeps your heatsink happy and your system silent. So next up, we have the GPU. This one is a little tricky because graphics cards are basically portable heaters, but there are still options. If you're going for a workstation or media PC, look at passively cooled GPUs like the ASUS GT1030 Silent or the Palette Calm X series. For gaming, you want low TDP GPUs like the RTX 4060 or RX 7600. Pair them with a case that uses the chassis as a heatsink and you're absolutely golden. And remember, a quiet GPU doesn't need to be fanless. Many modern cards have passive fans that stop completely below certain temperatures. That's basically silence on demand. Then we have the power supply. Power supplies are often the silent killer of your quiet dream, quite literally. So a cheap fan whine can completely ruin your whole gaming experience. So look for fanless power supplies like the Seasonic Prime Fanless or the Silverstone Nightjar. They use massive internal heat sinks and smart airflow design to stay cool at about 500 to 600 watts, so no fan is required. If you can't go fanless, grab yourself a hybrid PSU like the Corsair RMXX, because this stays silent until you push it past 50% load, basically. Next up, your case. So here's where things get exciting. Your case becomes your cooling system. So fanless cases like the Streacom DB4 or the HDPLEX H5 that I mentioned previously use thick aluminium panels that directly absorb the heat from your CPU and GPU via copper heat pipes. These designs give you up to about 300 watts of passive cooling capacity, which is enough for most mid-range systems. Mount them vertically and you'll boost your natural convection by up to 20%. So next up we have memory. So SSDs themselves are naturally silent, but NVMe drives can get hot. So use thermal pads or passive heat sinks for M.2 drives. Avoid spinning hard drives unless you're building a NAS because they're exceedingly noisy and vibrate. RAM itself doesn't often need cooling in a fanless setup, but low-profile heat spreaders can help maintain that stability itself. So now you know how to build yourself and combine all of these components so that you have efficient CPU, a cool GPU, a fanless PSU, and a passive chassis. You're not just building a PC, you're building an ecosystem of complete silence. It's not about brute force cooling, it's about balance. Every watt you save is a decibel you don't hear. And the beauty of this, these systems are practically maintenance free. So there's no dust, no fan replacements, no noise creep over time that you can sometimes see. So now you know that silence isn't just possible, it's engineered. It's a reminder that sometimes the most impressive builds don't scream for attention, they whisper with precision. So if you made it this far, thank you ever so much. This one was a bit of a nerdy one, and I always appreciate you hanging out with me and letting me dive into the science of quiet computing. I actually really enjoyed this one. You're the reason I get to nerd out over cooling systems and airflow and all the weird tech ideas that usually make a difference. So here's to smarter builds, cooler temps, and quieter desks. Please don't forget to like, drop your silent setup ideas into the comments, and hey, if you enjoyed the calm, hit that subscribe button. And let's keep hearing absolutely nothing. Thank you ever so much for watching, and take care, guys.